Text, Indeed. 1 search. All jobs. At Indeed ENG. Monthly tech talks at Indeed's Austin headquarters. Engineering.indeed.com. A man stands at a podium on a stage, a laptop open in front of him.
Hello guys, once again, welcome to the final Indeed engineering talk of 2014. As Jack mentioned, we're going to have a talk followed by a brief demo, and then we're going to break out into a workshop, and we'll have lots of people around to help you get your own clusters up, or we also have a publicly available Imhotep instance up, so even if you don't have your own AWS account or your own data, we can still help show you how to use Imhotep, and then you can get it running later.
A slideshow begins.
So Jack said, my name's Tom Bergman. I'm the product manager at Indeed San Francisco. I moved out to San Francisco about 3 months ago with a new team to start building a new product for Indeed. Mini pitch. For those of you who've looked for jobs in the past year or so, maybe you remember everybody has this big spreadsheet, and you have all the companies you've talked to and the jobs and where you are in the process and what you have to do next. And so what we're trying to do is build a way to just magically track all that for you and automatically give you awesome recommendations. So over the past couple of months, we worked really hard, and we rolled out the very earliest V1 to a very, very small group of test users a few weeks ago. And I was really excited. We had this new product out. What's happening? Is it working? Are people seeing it? So for me, in that case, I turn to Imhotep and I say, is it working?
Slide, is anybody there? A screenshot shows a graph with a line rising sharply up, then down.
Is anybody there? So I go and I hit Imhotep and I say, are we getting traffic? And so you can see here, I have a query at the top hitting Imhotep, and we have no traffic, and then magic, we have traffic. Yay, it's working. Okay, cool. So it's on, but are people using it correctly? Are the features working? So again, I'm going to go and I'm going to ask Imhotep, is it working?
Slide, does this thing work? A new graph.
So I'll say, hey, are these features on? Are people clicking these buttons? Are these pages loading? Are these events firing off? And I can say, okay, yes, they are. That's awesome. So I can put in a query about some different things we're trying to track and see if they happened. And I can also say, like, hey, how is this doing against other products we have at Indeed? How is this doing against previous versions of pages? So I can say, are we winning?
Slide, a graph with lines rising and falling.
And so you can see here, I'm actually querying 3 separate data sets. These are completely different data sets that have different bits of information, but I can say, how is this new product doing against the previous desktop version? How about against the previous mobile version, etc. And I can graph all 4 of these at once and kind of pick through it.
Slide, a graph with multiple lines rising and falling.
In addition to simple questions like these, I can go and ask a little bit more complicated questions like, okay, we're showing a promo to users after they return back to the site. Based on different test groups and how long they're away from the site, what is the response rate? And I can put in a query to Imhotep and get a response bucketed by milliseconds that tells me how these response rates change. So cool, that's awesome. I can go and I can ask Imhotep and get all the answers to my questions. And I like that, but it doesn't help you guys very much. So I want to get into how you guys can start using Imhotep to do the same kind of stuff. First off, should cover what is Imhotep. Probably heard this 1,000 times, but I'll reiterate. Imhotep is Indeed's highly scalable open source analytics platform. We just open sourced it a few weeks ago. We're really excited about it.
Slide, Imhotep open source included.
What does the open source contain? There's really 4 kind of main parts to Imhotep. So we have the Imhotep daemons. This is the back end, the things that are actually running those queries and producing the results for you. We have Imhotep query language, or IQL. This is going to be the query language that we use to ask questions to the daemons and get response back. We have we call the IQL web client. This is a web-based app or a cloud-based app that you can go to and type in a query and get responses right back in your browser. And then finally, we have this TSV /CSV uploader. And this is another web-based tool where you can just drag and drop or upload a TSV of information, and we'll suck that up into Imhotep and make it searchable.
Slide, a bullet point list.
So what does Imhotep do? There's 2 main things that we use Imhotep for that makes it really valuable to us. First, it lets us really easily upload files and compress them to very small sizes so we can get data into Imhotep really quickly. And then once the data is there, we can do basically real-time interactive queries on it and get responses back in real time. So that's what's awesome about Imhotep to us. But Imhotep is not the first analytics tool we built at Indeed. We built some of the predecessors to Imhotep way back in 2010. And Imhotep's the latest in this line. Over the course of building these different tools, we've learned a lot about what makes an analytics platform work, what makes it really useful, what's really important to be able to have it be successful in the company. And so I wanted to go over kind of this philosophy that we took with us in building Imhotep, why we built it the way we did, so that you can kind of understand those choices.
Slide, a bullet point list.
First off, we think it's important that it's interactive. You need to be able to ask a question and very quickly get an answer back. We want to try to lower the barrier of entry to asking questions of Imhotep. So it's not hard to ask a question. I can ask a question, I get an answer right back. If you're having to wait a really long time for a response, you're going to ask less questions, you're going to understand your data less. And because it's hard to formulate queries and it takes a long time to get answers back, less people are going to use it as well. So we just wanted to really lower that barrier of entry to asking questions and to asking follow-on questions. If any of you guys have tried to do big data stuff in Hadoop, you probably all know the pain of executing an incredibly long Hadoop query that then returns absolutely no results. So you wait 12 hours and you get nothing for it. That sucks. It's horrible. And so with Imhotep, we wanted to not have that happen.
Slide, time to the right question.
So we can ask a question. If it's wrong, first we'll get an error before it even executes. But if it's not kind of directionally the right question, it's not quite the question we wanted to ask it, tweak it a little bit more, and finally get the answer.
Slide, ask all the questions. Rows of arrows curve back on themselves, with the word insight underneath the final arrow.
In fact, in reality, it really looks a lot more like this most of the time. Ask a few questions, see something interesting, pivot a bit more, try to find out what's really interesting about it, and keep going until we find the really, really cool stuff, and then do a bunch more queries afterwards that maybe aren't quite as cool. But they're all so fast and so real time that it doesn't matter. And by having it so easy to ask these questions, everyone in the company can also get involved in it more.
Slide, ground truth.
The other thing that we think is really important is to have the real, true data there. We believe that we should never downsample the data, because when we downsample the data, we make it really, really hard to drill down into the details and get good results. One way that people often make analytic systems fast is by doing aggressive downsampling. Anybody here who uses Google Analytics has tried to drill down into something very tiny and just get nonsensical results, because they do so much downsampling, you can't really understand it. So what we want to do is make sure that we have the real data there accessible to us. If we are doing, even if you do understand what's happening with the downsampling, there's assumptions that are made, and if you don't understand those assumptions, you're going to get the wrong answers, interpret the questions the wrong way. So just real data.
Slide, a table.
And that lets us do things like, for example, here's just a query I pulled up for this talk. I'm looking at just one day in September in the country of England, where the user came from Belgium and was looking for the query administrator. What are the top 10 titles, and what is the click-through rate on those titles? And I can just easily run that query and see the precise real numbers for this very, very tiny data set from a while ago. So we think that's really powerful. It helps us look into outliers. It helps us look into trends. It helps us do all kinds of things. So what else do we think is really important? We thought it's really important to have a web-based tool to facilitate sharing. So if I have a program running on my computer, I have to get it set up. I go and I execute it. I download the answers, and then I want to get somebody else's opinion on it. They have to make sure they have the tool installed. They have to go then figure out how to do the same query that I did and get the same answers.
Slide, show me the data.
With a web-based tool, I can do a query. I can look at the answers. I can then copy that link, send it over to somebody else in my team, and say, hey, have a look at this. And they can immediately see what I'm doing. They can tweak the query a little bit, send it back to me. Well, what about this? And we can have this conversation here. So by having this web-based app that easily allows sharing, we kind of generate this data-driven culture where we can say, show me the data. Don't just make an argument. Actually show me what's really happening.
Slide, a screenshot of a text conversation.
So when PMs at Indeed talk to each other, our conversations generally look a lot like this. Hey dude, here's a query. Blah, 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 here's another query. Oh really, here's another query, and so on. And so sometimes even when we're getting into really hairy tests, we'll have Jira issue comments that look like this.
Slide, a screenshot of a longer text conversation with multiple links.
Shout out to the ridiculous amount of work Jan did to prove a point here.
Slide, cache rules everything around me.
So what else is really important? Talked about making it really easy to share results with other people. If I execute a particularly long query, I don't want to have somebody else have to wait at all to see it. I want us to be joining conversation right there. So in Imhotep web app, we do really aggressive caching of results so that I can do a query on my computer, I can send it over to someone in my team, and instantly they have the exact answer there. We don't have to wait for it to execute on them and then send it to someone else and wait for it to execute. It just all works really fast and gets us out of talking about how to get the data to actually talking about the data itself.
Slide, easy access.
Queryability. It doesn't matter how fast you can get results if you can't easily formulate queries to get at the results. We want to have a query language that's expressive enough that we can ask most of the questions we want, and that we don't have to, that's not so incredibly verbose that it takes forever to write it. So before I get into what this query language looks like, it's probably helpful for me to talk about what the data inside Imhotep looks like. So Imhotep data structures. The primary data structure of Imhotep is a data set. You can think of data set as being like a table in a relational database.
Slide, Imhotep data structures.
So we'll have maybe one data set that's all of our searches, or one data set that's all of our applies, or something like that. So once we have this data set, any query we're asking is going to be a query we're asking to this specific data set. Then the key item of the data set, which is kind of the atomic unit of Imhotep, is going to be the document. And that's what is this data set based around. And you can think of a document as like a denormalized row in a relational database. So we have this row, it's one item, and then we're going to have all the different information about that item. The next thing is a field. You can think of a field as being like a column in a database, and you can think of a term as like being a value. So for example, maybe we have a data set that's about searches. We might have one field that's the number of results, and so maybe it's 10 or 5 or 7. And we could have another field that's the job IDs, we're a job search company, so the job IDs that appear in that result. So maybe 175, or maybe we want to know the number of which order were clicked, 532. So this field, this term can be either a single thing or it can be a series of things that are all associated with this field or this attribute of the document. Seeing as how the data structure can be kind of compared to a relational database, we thought that it made a lot of sense to use some query language that's reminiscent of relational database. So we made a query language called Imhotep Query Language, IQL. This is an expressive SQL-like language for aggregate analytics. So if you know SQL, you should be able to pick this up really quickly. If you don't know SQL, you should still be able to pick this up really quickly.
Slide, IQL queries, requirements.
The base query is incredibly simple. There's only 2 requirements. Choose a data set, so which table are we querying, which information are we querying, and we have a date range. Imhotep assumes that all the documents are time series documents, and so when you're choosing the date range, you're choosing how big of a data set are you querying, how much data are you looking at. So if you just put in those 2 things, data set and date range, it's going to return to you the number of documents in that date range for that data set. But we can also have a lot of things we can add on to this query. So we have filters.
Slide, IQL queries, optional.
Filters are things like where field equals term, or field greater than term, or field in term 1, term 2. We also have group by. So if you're familiar with SQL, we can group by things, but we can also do a limited group by. So we can say just group by users in test group 1 and test group 2. And it will do a group by limited to just those 2 groups. We also have metrics. Like I was talking about before, there's a lot of different attributes of the document that you might want to store in a data set. For example, for a click, you might want to know how much revenue that click took, or how long it took for someone to do that click. So those are all times, plus, modulo, all kinds of different things to manipulate the metrics to get whatever we want. So let me walk you through an example query here.
Slide, IQL dataset.
So first, the data set. So we're going to say from search results, in which case search results is the name of the data set. We put the data set first in the query because it enables us to do really smart autocomplete. If we don't know what the data set is, we can't autocomplete it.
Slide.
Next, we have a date range. So in this case, we're going to be asking for all the documents between December 5th of last year to December 10th of last year, those 5 days.
Slide.
Then we have some filters. So we have this filter where country equals Ireland, and we also have this inequality filter where the job age days is less than 1. So it's going to be giving us all the search results that were in the country of Ireland and that were less than 1 day old.
Slide.
We can then do a group by. You can group by any of the fields, but we have a special group by which is called time, which accepts inputs like days, minutes, hours, seconds, etc. So you can just easily put in any kind of time that you want to slice it by, and it'll intelligently interpret it.
Slide.
And then finally, metrics. We can choose multiple metrics separated by comma. We could, for example, if we wanted to add those two together and do clicked plus count, although it wouldn't be super meaningful. So in this case, clicked is going to be the number of clicks on this result, and count is a special metric, meaning the number of documents in that set. So we're going to get the number of clicks and the number of jobs.
Slide, IQL example results, a table.
So we'll put in a query, and we'll get a result like this in a table form. So we can see, there's a group by 5 days, so we have 5 groups. We have the clicks for the groups and the counts for the groups.
Slide, a graph.
And then we can just click over to a graph and then immediately see a graph of the same thing as fast as the JavaScript can draw it. Cool, you can query the data, you can ask lots of questions about it, but that's only as good as the data that you have in there. And if it's not easy to get data into a system, you're not going to put it in there, and then you're not going to have it to do any queries on. So extract, transform, load is a data warehousing term, often referred to as ETL. This is like how we get the data out of the system it was in and into the new system that's going to do the analytics on it. So ETL for Imhotep, we tried to make as easy as possible. We use it ourselves, and we want it to be really easy.
Slide.
So first extract, you have to get your data out. If your data schema is really complicated, this part's going to be hard. If it's not, it won't be.
Slide, a bullet point list.
So next, transform. So we have a TSV uploader that's going to make it really easy. The only thing is there's a couple things that you have to do. First, denormalize your data. So for example, you can imagine if you have all the information about a document that's stored in maybe multiple databases, you might want to do a big join across all those databases and merge them together into one big table so that then you have all the information you care about that can then be uploaded. Then you also have to do a little bit of stuff on formatting, so making sure the header is correct, the date format needs to be in Unix format. There's some things around what the title of the document is. But we actually have a linter script that'll take care of most of that for you, so it should be pretty easy, and it's all outlined in the documentation. One more thing I can add is that as part of the configuration of the formatting, you can configure whether you want the fields to be tokenized, whether you want them to be bigrams, and it'll just do that automatically for you when it's creating the data set.
Slide, a bullet point list.
So some example data sets we have here at Indeed, job search, ad clicks, resume contacts. One of the hardest things about setting up the data set is actually thinking about what do you want this denormalized document to be. So in job search, for us, we have one document for every load of a search results page. So this is going to be the primary document is a page load. As it is a page load, it doesn't make sense for that to be very detailed information about an individual job, since there's going to be 10, 20, 40 jobs on each thing. It's a lot of information to join in and isn't really applicable to this. Likewise, we have one thing that's ad clicks. It's just all of the sponsored clicks. So for this case, it makes sense to be what's the revenue associated with it, whereas that might not make sense in other things. And resume contacts, you can imagine. So really the main thing, think about what types of questions you want to ask, and make sure that the data set that you're going to be putting into Imhotep is going to allow you to answer those questions.
Slide, load.
And then once you have that data ready, we go into the load step, which is we have this TSV, CSV uploader. You just drag it in there or go to the website and upload it, and then it'll slurp it up into Imhotep, and in a very short period of time, you'll be able to query on it. For more complicated things, we also have a Java API so that you can actually build your own data sets and upload them through the API. In practice at Indeed, we actually do about 50-50 each of these. One of the things we really liked about the TSV uploader is that when we get data from outside sources, or from Excel or from other programs that we're using, it's pretty easy to get that data into TSV format. And so we found that that was kind of the minimal path that we could get things up in Imhotep. So once it actually puts it in Imhotep, how does it store it? We're a search company, and we like to go to search when we're thinking about how to solve this. So we use a data structure called an inverted index, which is a really common data structure used in search.
Slide, a bullet point list.
It has a couple really good attributes, which is why we chose it. One, it offers massive compression. So we have a sample data set that you guys can see in a little bit of Wikipedia data. Uncompressed, it's about 2.5 terabytes. And then once we compress it into inverted index, it comes out less than 250 gigs on disk. So that's really, really nice compression. It gets the data very small and lets us query it very quickly. Also, by being an inverted index, it lets us do Boolean searches much faster than if you're doing a query in just a traditional database.
Slide, a bullet point list.
As we've said a number of times, it's open source. The open source package is able to be run on basically any modern Intel chipset, really any kind of modern processor, really. It's not going to run on a cluster of smartphones yet, but who knows. We also have it wrapped up so you can really easily get it deployed into AWS via a CloudFormation script. So if you want to do AWS, it's super fast. You can get up and running, you guys know, in just basically 3 steps. So you create the S3 buckets, you create the key pair, you run the script, and then done. You have an instance up and you can start working on it. So that's the talk portion. That's I think everything you need to know to start getting into Imhotep. Before we hand it over to Q&A, I want to go and demo some of the sample data sets, explain to you what they contain, and kind of guide you towards some interesting queries you might want to do.
Slide, a web page, demo.imhotep.works/IQL/.
So our first sample data set on our demo cluster and on the sample data set page in the documentation, we have it called NASA here. And this is a selection of Apache logs from NASA's public website from July to September, or just basically July and August of 1995. It's a public data set we uploaded here. Probably most of you are familiar with Apache logs, so we figured it would be a good place to start.
He clicks the time range boxes, bringing up a calendar to select the dates. He clicks the Run button, bringing up a table with one line.
So right now I have this query ready from NASA, selecting the data set, and a time range of, it's a little smaller, July through the end of August, and I'll run. And we can see in this data set, there's 3.4 million documents, so 3.4 million Apache logs during this 2-month time range.
He hovers his cursor over the list of fields on the left side of the page.
Now I can walk you through some of the cool fields. So we have all of the fields here are indexed, and when we click on it, it's going to do a group by and show us all the most common terms. So for example, we have this field here called host.
He clicks host, bringing up a table.
It's a little bit misleading, but in this case, host is where the source of where this traffic came from. So as you guys can see, in 1995, Prodigy was still very, very popular, as was AOL.com. We can then go click on method.
He clicks, bringing up a new table.
And this is going to give us the method. As you can see, primarily gets with a few heads and posts. We can click on response, and this is going to be the response message. We got a lot of 200s, some 404s. Probably the most interesting field here is going to be URL.
He clicks, bringing up a new table.
So this is the URL that was requested. And if we look here, the most common requested URLs, we can see that 1995 was a much jiffier web than we live in today. So it's kind of hard to see what's going on through all these images. So what I'm going to do is I'm going to add a filter here to get rid of it. So I'm going to add a regex filter on URL to exclude all URLs that contain .gif.
He types the filter in the where box at the top of the page.
So we have now removed all the GIFs. So now we're looking at the top 1,000 URLs that don't end in .gif. If we scroll down, we can see here at number 7, we have shuttle countdown liftoff.html. Now I happen to know that this is the URL for the much publicized at the time shuttle countdown liftoff page. So this is going to be where people could go and see a countdown timer before a shuttle takes off. So if I click on this here, it's going to automatically add it into the where as a filter.
The URL appears in the where box under the previous filter. He clicks run.
And if I were to execute the query again, I'll see there's just one URL now because I'm looking for all the URLs that are this.
He types in the group by box.
So if we want to then go and pivot, we can then look at time. So I'll set time 1 day and run. And what we'll see here is the number of requests to shuttle countdown liftoff.html per day.
He clicks the graph tab, showing a graph with a line spiking sharply up and down.
And looking at this, we can see that traffic was kind of low, and then it spiked up massively on July 13th. Now I happen to know that July 13th, 1995, there was a Discovery shuttle launch that people talked about a lot, and so we can see there's a huge surge in traffic to this countdown page when the shuttle is taking off. And we can, in fact, go from days to hours, get more granularity very quickly, and we can see that, in fact, everyone was there early in the morning when the shuttle was taking off, and then didn't come back after. I'm going to move on to the next data set. We have Wikipedia.
A new query page with dates in the time range boxes.
So this data set here is a public dump of all the pages in Wikipedia which received traffic during the month of September. This is, again, a huge data set. It's raw 2.5 terabytes. Even on disk, it's 250 gigs, so it's very, very, very big. I will call out the unit. So the document for this index is actually an hourly roll-up of logs for a page. So if we're going to do a query and look for counts, it's going to give us 24 counts per page each day, because each day has one document per hour. So instead, what we're going to want to use is a metric, num requests, which is going to be the number of requests. So I'm going to go execute this now, and hopefully it'll go fast.
He types in the select box, bringing up a table with one line.
And we'll see how many requests there were in the entire month. So we see there's about 6.8 billion requests to Wikipedia during the month of September. Now, that was fast, but I still don't want to anger the demo gods here. So I'm going to shorten the time range a little bit. We're going to go just down to, we'll pick a seemingly arbitrary date of September 19th.
He clicks the title field in the left-hand list, bringing up a table.
And I will filter on title. There's a couple other things here. There's the categories, the links out, which is going to tell you all the links out of that page, requests, title words. But I'm going to focus on title since I think that's easiest to get across. This is giving me title top 1,000 by count. Count is not super meaningful in this index, so instead we're going to ask for the top 1,000 by num requests.
He types in the group by box.
And it's going to resort it. And what we're going to see here once this query executes is for September the 18th, what are the top pages of Wikipedia by the number of requests they received.
The sorted table appears.
Let me kind of make it a little bit bigger so people can see. So top is the main page with 13 million, followed by 2 undefines that appear in every day, and then less Unix. I don't know why this is here, but it's here in every single day for September. So maybe you guys can dig into it and find out. It's a mystery to me. But if we scroll down a little bit, we see the Scottish independence referendum is the next highest thing. And this makes sense because it turns out that September 18th of this year was the day of the Scottish referendum. And if we scroll down a little bit further, we see that Scotland was number 12. So that's cool. It makes sense. These were both very popular on the day that they were happening. But we can actually go and say what was the popularity of these pages throughout the entire month. So what I'm going to do here is I'm going to create a second query here. This is going to let us do 2 queries at once.
He clicks the plus button at the top right of the page, adding a new set of query boxes.
I'm going to then set this to September 1st through about, let's say, the 25th. And I can press here to copy it down.
He clicks the down arrow button next to the time range box.
I'm going to click here to add the title Scottish referendum, and also click here to get Scotland.
He clicks the 2 links in the table.
But I'll just delete this and delete this. So now we have 2 identical queries looking at the time range, September 1st through the 25th, comparing the title Scottish Independence Referendum 2014 to title Scotland. I'm going to go ahead and change this group by to time 1 day and copy it down again. And then we'll be able to see how the popularity of these 2 related queries changed over the course of the month. So I'm going to run this, switch over to a graph. So this is that aggressive caching I was telling you guys about.
A graph appears with 2 lines, both showing a gradual trend upwards, then a sharp spike up and down.
So as you can see at the beginning of the month, there was basically very, very little interest in Scotland or the Scottish independence referendum. They both go up at the same time around the 8th. And then they peak on the 19th, 1 day after, and then go back down to normal. And you can see these lines track each other very closely. It seems that there were not very many people interested in Scotland outside of the context of the Scottish referendum. So that's the Wikipedia data set. It's very, very big. There's lots of cool stuff in it. I highly encourage you guys to explore it. But I'll leave some of those mysteries for you and move on to our final demo data set, which is called World Cup 2014.
A new query page with dates in the time range boxes.
So earlier I said that Imhotep expects that the data is going to be a time series. So all the tools were built around it being a time series, and we use time series on all of our logs, so it's really easy. But occasionally we need to use it for non-time series stuff, and it can easily do that. All you have to do is just set the timestamp for everything to be one specific day, or set the title to be 1 day. So we've just indexed this data set all on this day, July 1st. If I query July 1st, I'll get all the data in the data set. And this data set, I will say the document for it is a player in the World Cup. So when I ask for counts, it's going to give me the number of players matching my query. So I'll just run this now, and we'll see.
A table with 1 line appears.
In World Cup 2014, there were 736 players. So we have a couple different fields. We have age, the age of the player, captain, it's a Boolean, are they captain or not? What club did they play for? I think a lot of these are fairly easy to understand. I will say rank is the rank of the team, so all players on the team are going to have the same rank. And finally, selections is going to be the number of times they've played for their national team. So what I'll do first is we'll just look at we'll do a group by captain.
He clicks inside the group by box and selects captain.
So we're going to group by, is it captain, yes, no? And we'll go, let's see how the age of a captain compares to other people. So I'm going to add age divided by count.
He types in the select box.
So whenever we want to get an average in Imhotep, we're going to do divide by count. So in this case, this is going to be age of the group divided by the number of documents in the group, or age of all the captains combined divided by the total number of captains.
He continues typing in the select box.
And then we'll also look at selections divided by count, or the average number of selections. We will see here that captains are on average about 5 years older than non-captains, and have played on average about 3 times as many games for their national team. We can also, for instance, since we know that there's only 1 document per player, we can do some fun stuff and say, let's get some information about the captains.
He types in the where box.
So we'll say where captain is 1. Let's group by player, which is going to be their name.
He types in the group by box.
And then we'll also group by country. Here I'm going to add closed brackets to say, don't show me results if they're 0. So it's not going to give me the cross product of everything. It's just going to give me the country for that player. I'll do the same thing with club, the club they play with normally, and their age.
A new table appears.
And when I get it, we'll see that, forgot to bracket out age. Here we go. So then we can see the oldest captain in the World Cup is Mario Yepes, sorry if I'm mispronouncing that, from Colombia, followed by the captain of Greece, Honduras, and so on.
He clicks the club link in the left-hand list.
I'll do one more just to show you. We can look at which clubs are contributing the most players here. So we'll just look at club by count, and we'll see. Oh, that's still giving me captains, maybe?
A new table appears.
There we go. All right. Yeah, so we can see Barcelona sent the most players, followed by Bayern, followed by Manchester United. So these are the 3 sample data sets we have. I'm going to go over to Q&A briefly. So if you have any questions, answer any questions, and then we'll open up the workshop, and people can go around and help you get started on using Imhotep yourself.
Text Indeed. One search. All jobs.